Hello and welcome to the live lesson on similar triangles. So by the end of today's lesson, you should be able to solve problems involving proportional relationships between similar triangles and describe the connection between slope and similar triangles represented on the coordinate plane. So let's review some vocabulary. We have corresponding sides. These are sides that are in the same position on two similar triangles. We have a proportion. This is an equation where two ratios are equal to each other. Remember, ratio means fraction. A proportional relationship is a collection of pairs of numbers that are in equivalent ratios. And then similarity means to have the exact same shape, but not necessarily the same size. All right, so let's look at characteristics of similar triangles. When two figures are similar, it means that they must have all three of these characteristics. If they don't have all three, it's not similar. So their corresponding angles must be congruent, the corresponding sides must be proportional, and all of the sides must have the same proportional relationship. Again, it must have all three of these in order to be similar. All right, so let's determine, are these triangles similar? The steps to do this is we are first going to determine corresponding sides. We will then use one set of corresponding sides to set up a scale factor. We will simplify the scale factor, and we will then repeat steps 2 and 3 with an additional set of corresponding sides to check to see if they match. If they match, they are similar. If they don't, they are not. All right, so let's look here. These triangles are in the same orientation, so we can easily see which sides are corresponding. We can see this 12 and this 6, so we're going to start there. We're going to set up with the smallest side on top and the bigger one on the bottom, and we're going to test to see what this ratio is. We are going to simplify it. So to simplify this, we can simplify 6 over 12 to 1/2. Okay, so we know this ratio is 1/2. We are now going to pick another side and do it again. So we can pick this 9 and this 18. So 9 over 18. Again, we can simplify that to 1/2. Just to be sure, we're going to go ahead and do it to the third side. So we have the 16 and the 8. 8 over 16, this also equals 1/2. So we can see here that all three of these are 1/2. So yes, they all match. These triangles are similar. All right, so now it's your turn. Go ahead and pause the video, try this, determine if these are similar, and then come back and restart the video when you're ready to review. All right, so let's first find corresponding sides. They're in the same orientation, and we do have this right angle here, so it's pretty easy to determine which sides are corresponding. So we know this 6 and 9, we'll start there. So 6 over 9. Well, if we simplify this, 6 divided by 3 is 2, 9 divided by 3 is 3. Okay, so 2/3. Now we can look at this 10 and this 15, okay? So 10 over 15. Well, 10 divided by 5 is 2, 15 divided by 5 is 3. All right, so this is 2/3. Now we're going to do it with one more side. So 8 and 12. So 8 over 12. Well, 8 divided by 4 is 2, 12 divided by 4 is 3, 2/3. All three of our ratios are 2 over 3. So yes, these triangles are similar. All right, great job. Now let's take this one step further, and we're going to find the missing side. So in here, we have similar triangles, and we're trying to determine what the length of the missing side is. So our steps. First, we are going to determine the corresponding sides. We will use the corresponding sides to set up a proportion with a variable in place for the unknown side, and then we will solve the proportion for the variable. Remember, a proportion is just two fractions set equal to each other. So let's take a look here and let's find our corresponding sides. Well, one thing we can look at is these angles. We can easily see, because the orientation is the same, which sides are corresponding, but sometimes it's not always like that. So you want to look at your angles. These right here means that they're a right angle. So those angles are congruent. We can see here, this one with only one line, that tells me these angles are congruent. And then this one down here with 2 lines tells me that those are congruent. So knowing which angles are congruent can help you with which sides are, because the sides that are next to those angles will be corresponding. Okay, so let's go ahead and set up our proportion. We're just going to pick one pair of corresponding sides. So we can pick this 3 and this 9. We're going to put the smaller one on the top, so 3/9. Now, on the other side of your proportion, whatever number goes in the same triangle must be on the same side. So our 4 right here must go on the top because the 3, which came from the same triangle, was on the top. Now we're picking the 4 because that corresponds to our unknown side, which is going to be x. You must pick the one that corresponds, and you're going to set up the proportion. So we have 3/9 is equal to 4/x. Now, whenever you have a proportion, remember that we are going to cross multiply. So we are going to do 3 times x is equal to 9 times 4. Well, 9 times 4 is 36, so 3x equals 36. We are now going to use those inverse operations that you learned back in an earlier module. We are going to divide both sides by 3. Those 3's cancel. 36 divided by 3 is 12. So we know our unknown side is 12. Okay, so that's how we're going to find the missing side. Now it's your turn. Go ahead, pause the video, come back and restart it when you're ready. We're going to find the missing side, which is our x over here. Okay. All right, so let's come back and look at this. So we're going to first pick our corresponding sides. Now, it's a little bit different here because our orientation is not the same. So we're going to look at our different angles and figure out which sides are corresponding that way. So in between this one and this one, we have a 5. Okay, so we're just going to go ahead and use this 5, and we're going to look over here what's in the same spot. So what number is in between our small one and our one that has 2? Well, right here is 7. So that tells us the 5 and the 7 correspond. Now, same thing. We can look at this x here. This x starts at the one that has 2 lines and it goes to the nothing, the one that has nothing. So over here, we're going to start at the 2 lines and go down to what has nothing. Well, that gives us 6. So we know x and 6 are going to correspond. Again, you have to make sure that this 5 and 6 are on the same side because they're in the same triangle. And now we're going to go ahead and cross multiply. So 5x is equal to 7 times 6. 7 times 6 is 42. So 5x equals 42. We're going to use those inverse operations that we learned and divide both sides by 5. These 5's cancel. Now, x, you can do a simplified fraction or you can convert it to a decimal. If we convert to a decimal, we do 42 divided by 5, which gives us 8.4. So our missing side length is going to be 8.4 centimeters. Always make sure to include your units. I knew it was centimeters because up here we had centimeters in each one of our measurements. Okay, all right, awesome job. Let's move on. So now we're going to talk about overlapping triangles. Overlapping triangles is when we have 2 triangles mushed together into one. So the biggest tip I have for you is to draw out these triangles as 2 separate triangles. When you do that, it can make looking at them a little bit easier. So we know we have this small triangle right here. And then we know we have this bigger triangle like this. So those are our 2 triangles. We're going to take them and we're going to draw them out to be 2 separate triangles. So first, if we take this smaller one, so we're going to draw this smaller one out, we can see the 6 is here, and we can see this 0.9 over here. Now we're going to draw the bigger one. Now, pay attention with this bigger one. We have H over here, but down here, it needs to go all the way from A to D. We don't have that measurement. So we have to take the measurement that it gave us from B to D and from A to B and add them together. So 6 plus 12. That's going to give us 18. So our 18 is going to be on the bottom here. Okay, so always pay close attention to which measurements you are using. Now we're going to go ahead and set up our proportion. So we're going to use our similar sides. We know that this 6 and this 18 is corresponding because they're both on the bottom. So 6 over 18 and then 0.9 over h. We are going to go ahead and cross multiply. So we're going to do 6h is equal to 0.9 times 18. Well, 0.9 times 18 gives us 16.2. So 6h is equal to 16.2. Divide both sides by 6. The 6's cancel. 16 divided by 6, this is going to give us 2.7 meters. Again, make sure to write your units. We knew it was meters since there's a meters in each one of these. So our unknown side is 2.7 meters. All right, so now it is your turn. Go ahead and solve this one. Pause your video, draw out your triangles, and solve for our missing side. Come back and restart the video when you're ready to review with me. All right, so let's first start with drawing out our triangles. So we know we have this smaller one right here, and then we know we have this bigger one right here. So we're going to draw these out as two separate triangles. So we have our smaller one. It has an 8 down here and a 5 over here. And then we have our bigger one. We know this X is over here. And then again, we don't know what this is. We need to add together our 16 and our 8 to get 24 for here on the bottom. All right, so now we're going to go ahead and find our corresponding sides. So we know that this 5 and X correspond. We know this 8 and this 24. So 8 over 24 is equal to 5 over X. Okay, so we're going to set up our proportion and we're going to cross multiply. So 8 times X is equal to 5 times 24. Well, 5 times 24 is going to give us 120. So 8X is equal to 120. Divide both sides by 8. And 120 divided by 8 is 15. So X equals 15. And that's it. We found this missing side. All right, so now let's do a real world connection. Remember, when you're doing these word problems, you want to try to apply that FAST strategy that you've been learning throughout the course. Remember the FAST strategy. F is to find the important information from the problem. A is to ask yourself, what are you trying to find? S is to solve using your appropriate formulas or steps. And T is to test your solution. Check your work, determine if you've done it correctly. All right, so let's first go and use our F, and we're going to find the appropriate information from the problem. So what is important here? Nadia, who is 5.5 feet tall, is playing outside. The length of her shadow is 40 feet. A palm tree parallel to her has a shadow that is 260 feet in length. Determine the height of the palm tree. Right, now, it already gave us this really cool picture down here. It's not always going to give you a picture. If it doesn't, draw one out. It makes it a lot easier if you've drawn a picture out to help you see what it's asking you. So what's important here? Well, Nadia is 5.5 feet tall. The length of her shadow is 40 feet. A palm tree that is parallel to her, that's important, has a shadow that is 260 feet. Okay, so that's the important information. Now, ask yourself, what are you trying to find? Well, we are trying to determine the height of the palm tree. So we are trying to figure out what height that palm tree is. All right, now we're going to solve using the appropriate steps. Well, we can see here we have these overlapping triangles. So we're going to go ahead and draw out our triangles as two separate. So we'll start with the smaller one. We have Nadia, who's 5.5 feet, and then we have this 40 feet down here, okay? Now our bigger one, it's a little bit different than the earlier ones we've done. It's already given us this big measurement that goes across the whole way. So we don't have to add anything. We just know it's 260, and then we know this is h. So we're solving for this height of this palm tree. We're going to go ahead and set up our proportions. So 40 over 260 is equal to 5.5 over h. We are going to, again, we're going to cross multiply. So 40H is equal to 5.5 times 260. 5.5 times 260 is going to give us 1,430, and this is equal to 40H. We will divide both sides by 40. 1,430 divided by 40 is going to give us 35.75. So that is going to be the height of our palm tree. Now, you should always check your work. Checking your work helps to make sure that you didn't make a mistake. So we can go ahead and check our work here by setting up those scale factors that you learned at the beginning and seeing if they're the same. If they're the same, you did it right. So we know this one is now 35.75. So we can do 5.5 over 35.75, and it should be equal to 40 over 260. These should be the same. So if we were to go ahead and convert this to a decimal, 5.5 divided by 35.75, that gives us approximately 0.154. Okay, and then 40 divided by 260, this gives us approximately 0.154. Are they the same? Yes. So we know we did this correctly. We know our answer is correct. Okay, so now let's look at this next one. Go ahead and pause the video and try this on your own. We are looking for the height of this tree here. So go ahead and solve this, come back and restart when you're ready to review with me. All right, so first, find the important information. Okay, well, the important information is that this entire length down here is 24, this smaller one is 8, and this height here of this person is 5. We know that's important. Ask yourself, what are you trying to find? Well, I'm trying to find the height of this tree over here. And then solve. Okay, we have these overlapping triangles. Let's go ahead and draw out our triangles here. So we know our small one has this person that is 5 feet tall and then has this 8 feet. Again, here on the bottom, we have it going across the whole way, so we don't have to add anything. We know it's going to be 24, and then we are looking for this height of the tree. So we're going to go ahead and set up our proportion. So 5 over x is equal to 8 over 24. Well, 5 times 24 is going to be equal to 8x. 5 times 24 is 120. So 120 is equal to 8x. Divide both sides by 8. X is going to equal 15. So we found the height of our tree is 15 feet. Now we need to test our answer. We're going to do the same thing. We're going to test our answer by plugging in our values into the scale factor and seeing if they're the same. So we know this x is now 15. So 5 over 15 should equal 8 over 24. Well, let's see. 5 and 15. Well, 5 goes into 15 3 times. So this can just be simplified to 1/3. And then 8 goes into 24 3 times. So this can be simplified to 1/3. Do these match? Yes. So that means we are good. We got our answer correct. Great work. All right, we are all done. Thank you so much for coming and watching this live lesson. Don't forget to check out the toolbox for more help. It has awesome help videos, note-taking guides, and practice problems. And we can't wait to see you here again soon. Have a great day.